Welcome to the Interop. My guest today is Jon Kol. He's the CEO of Hyperlane. It's an interoperability layer that enables developers to permissionlessly connect any blockchain. Today we're going to be discussing Hyperlane's modular approach, the protocol's architecture, how it compares to other interoperability solutions, and the recent V3 upgrade. I'm also dying to find out why he thinks decentralized shared sequencers are not real. Before we get started, make sure to hit the like button, hit the notification bell, and subscribe to get notified when we release new episodes every week. And remember that none of what we discuss here on the Interop is investment advice. And if you enjoy this content, please consider staking with us. We're live on Evmos, Quicksilver, Osmosis, Juno, and Nolus. Just look for Interop in the active set. My guest, Jon Kol, is coming up next, right here on the Interop. Jon, thanks for joining me today.
Of course, great to be here. Watched a few episodes, a lot of fun, so I wanted to take part.
Cool. Were you at Cosmoverse?
No, I missed it.
Okay.
I happen to be one of those crazy people who decided to start like a crypto company when they have a young child, and have a wonderful, wonderful wife who does a lot and works still, and with the upcoming travel for like DevConnect and before. It was too much. We couldn't make it, but I would have loved to have been.
Yeah, it was good. I'm sure.
Yeah, it was great.
You've received some feedback on it already, but yeah, it was really great. This is the first episode we do after Cosmoverse, so maybe just to share some high level thoughts here. I thought it was great. Obviously, the team does an amazing job at putting on events, and this was no exception. It was much bigger than last year. Some notable things. I'm really bullish now on AZ. I think it was an interesting concept that we were sort of looking at before Cosmoverse, but seeing all the people working on AZ, all the research teams like Blockworks Research and Binary and this RMIT team and all the teams that are building on AZ or interested in building on AZ. It just got us really excited about it. So it's a space that we're going to be paying a lot more attention to. The other thing that I thought was really interesting was that there were very few VCs there, and I see that sort of as a bullish signal. There was us and Longhash and a few others, but it was very different from a lot of other conferences where every third person you meet is a VC. So I think
you're in the right spot.
Yeah,
it's former investor, I'll tell you, that's for sure. You're in the right spot.
Yeah. So that was great, and really just genuinely excited about where the space is heading, and to see all of the ideas of Atom 2.0 kind of starting to actually come together and people collaborating. I think that's really the sentiment, is that there's a real sense that people are collaborating and working together in constructive ways to push this vision forward. So. That's my kind of high level recap on Cosmoverse. But yeah, glad you'll be at DevConnect. We're also
it's going to be a lot of
hopefully
fun.
We can catch up there.
But I'll tell you, probably not going to get that same ratio as DevConnect. I suspect will be a much less friendly ratio insofar as the investor to person kind of in the arena. Let's call it.
Investor to person.
Investor to person in the arena.
Investors are not persons in the arena. Okay. Yeah.
I've had I've now I've people keep saying builders, and I'm like, we're not construction workers, we work in software. I can't say builder anymore. It's a sensitive topic. So person in the arena is my new preferred term.
Okay, cool. I'll hang on to that one. So, how did you become interested in blockchain interoperability?
Ooh, great story. Well, so I became really interested in it when I first got into crypto. So I get really into crypto around 2016 when a buddy, we recently graduated from Cal. We're at his brother's birthday, and he goes Jon, I'm gonna put all my money into Ethereum. What do you think? And I'm like, I don't know, dude. I don't know what to think. I barely know anything about it. All I know is you worked really hard for this money and you're going to put all of it into this thing. And he's like, dude, all my friends are doing it. So I think I should do it. And we spent the weekend on it, and I read about this thing, like this crazy internet computer that like anyone can build software on, and like you can't stop it. The Ethereum paper really was a lot of it was about creating financial services. And as someone who's been burned by banks multiple times in multiple countries through like many different interactions, I was like, this is so cool. Also, at the time, I'm working at Morgan Stanley, an investment bank, and I could see, like, I know now how some financial plumbing works, and I'm reading this thing, and I'm like, well, if this is real, this is legit, it's gonna fucking revolutionize everything I do. I go back to work the next Monday, and I'm like, you guys, we're gonna be out of jobs, not because of the algorithms, because everyone was worried on the trading desk, or human traders are all worried about like the algorithms going to replace. Like,
Yeah.
it's not human algorithms. It's gonna be these smart contract systems. Like, you don't know what's coming. And you learn more and more and more. And I become a little small time miner in the next few months and start realizing, wait a second, we have these internet computers, but they can't talk to each other? That's bananas. That's not going to work. I did like, oh, so okay, so like a blockchain doesn't know anything about information that's not endemic to it. Okay, it makes sense when you say it, but like, how is a world financial system going to be built on these rails? Doesn't add up. And so, really, from very early on, it was just kind of like, okay, I remember signing up for an internet connection like 1996. I was 6 years old. And like at first, my friends who were on they grew up in Israel, there were two big ISPs. Friends who were on the different ISP than mine, we didn't see the same websites. Like we both were like connected to the local portals. But by the next year, everything worked together, right? Suddenly we all had access to the same sites and it was like everything got connected. So I get into crypto by 2017. It's like, oh, this whole thing where, there's not a lot of these blockchains now, but there's obviously going to be a lot of them. And they'll be able to connect. Like that's a next year kind of thing. And then it was a next year and a next year and a next year. And really what I would say is like the first real inkling of hope was IBC going live. Um, at that time, I'm still an investor at Galaxy. I really spent my first 5 years in crypto as an investor. And you're seeing that, like, as amazing as IBC and the Cosmos ecosystem at large are, it felt like I always think of crypto and specifically of chains as like cities or like population centers. And it was pretty clear that our population centers are wide and divergent. And at best, at that time, Cosmos is either during the Terra days, Cosmos I thought was the second largest population center. Sometimes it's the third, but it's not the first one. It's not the largest one, right? The largest one, being the Ethereum population center and like the many myriad EVM chains that surround it, kind of like suburban cities, if you want to call it that. They couldn't talk. There was no, outside of something like Gravity, but there was no general message passing. There was no like apps that could traverse those population centers. And so that got me really going. And then came an opportunity to work on what it later became Hyperlane. That was like 2 years ago.
Cool. Yeah, I mean that's an analogy that I've heard a lot, right? This analogy to population centers or countries, and Sunny talks a lot about blockchains in this kind of geopolitical context, and I think it's an interesting one. And it's also an apt one, and feels very much like there are more connections happening between these population centers, if you will, or like these different domains of state, as I like to call them.
There you
You
go. I
know,
like that term. I'm going to steal it from you.
what's the biggest thing that interoperability solutions are competing on today? Like, there's a spectrum of interoperability solutions. I think there's like there's different axes to look at interoperability solutions on. So you have the trust versus trust minimized, trusted versus trust minimized, right? So on one end you would have like a multi-sig, on the other end you would have something IBC, and then there are gradients in between. There's also like this notion of like insured bridges or bonded bridges, right, where the game theory is different between each type of bridge. If you look at Hyperlane in that context, like, where does it sit on these axes?
Ooh, that's great. So let me answer the first question about like what are they competing on? And I think the the axes, the parameters that people think they are competing on, are what we talked about. It's a relation to trust assumptions. It's a relation to economic security. Ultimately, it's a relation to liquidity and users. And that's what I think. Those are different axes I think everyone thinks they're competing on. What I think the competition really is, from the perspective of an interoperability protocol, is about the interface. Like, whose interface is going to become the go-to interface? And I'm not talking about specifically like the UI. I'm talking about when you're an application developer or you're a chain, like, what do you do to communicate with others? Which interface do you plug into that? And then how often do you have to switch that interface? Does every time that the state of the art in crypto advances, does that mean you now need to have a new interface? And this is why we designed Hyperlane in a way to be to really have a modular architecture. And if you go through our docs, you go through our website, you'll see this term about modular security, interchain security modules. They come up a lot because one thing that we did, sorry, I'm getting some props. I think for most people, like, so in our space of interoperability, there's the product, which I would consider to be the interface. And then there's a big part of that product, which is this interface helps me communicate between chains. But how do I secure those communications, right? Because obviously security is imperative to this problem of interoperability, of connectivity. And for almost everyone, that is like, they just treat it as a singular thing. It's tight, it's at best, it's tightly coupled. It's two things, but they're tightly coupled together. And Hyperlane, like, nope, we decouple them. Those two things are separate. So on one hand, you have the interface. This is, think of it as like the Hyperlane mailbox, the thing that sends and receives messages. And on the other, now you're going to have a number of different security modules, and you can leverage those and use those based on the context of what your users are doing. And so some of those modules are not some, all of them are going to lie on different areas within those axes that you talk about. So some of them are going to take a much more trusted form. Some of them are going to take a much more trustless form. For example, with Hyperlane, you're able to secure the communications out of your chain just through like a singular key. That would be the most trusted setup. Or, recently, because Hyperlane is open and permissionless, anyone can wrap their logic as a Hyperlane security module. And actually, we're recently seeing Electron Labs, a team that was building ZK Lite clients, bring their ZK Lite client to Hyperlane as a security module. So now you have just two edges on the spectrum of, on one hand, you could have a setting for Hyperlane that is as maximally trusted, right? It's just a singular key, and hopefully it's someone nice. And the other is you have a zero-knowledge based Lite client where it is completely trustless. And both of those things can exist in the same system. Both of those things, most importantly, can be accessed from the same interface. And that's really what I think. That's what we're trying to compete on, and certainly, like, I'm sure different people have different feelings.
I want to dive in a little bit deeper here into this modular concept. I think I'm starting to understand what it means, but I'd like to maybe compare it or sort of compare it to this idea of a modular blockchain. So if you could, let's remind folks, like, what are modular blockchains and how that idea, that concept overlaps with what Hyperlane is doing. Because I think maybe in that context, it's more helpful to understand.
Oh, great framing. So I think the best way to explain modular blockchains, to keep it in simple terms, I'm a simpleton myself, so keep it easy, is thinking in a regular blockchain, what some people like to call a monolithic chain. I don't think that distinction is necessary, but that's okay. You get all the layers of the stack in a singular place, right? So you have the data availability that happens in the same place, the execution and the settlement. All three of those things are happening at the same place. And the notion of modular chains is to start separating that. So we see with, like think of layer twos as one version of separating, okay, so there we're taking out execution, but we keep settlement and data availability somewhere else. In a modular chain, you might separate it even further, where you have your own rollup and you're going to one place, like say Celestia, for data availability, and you're going to another place, maybe Ethereum, maybe your settlement layer of choice for that, and you're completely modularizing that stack in a sense that normally we have everything in the same place, and we're kind of like bought into it. So if I'm using just Ethereum mainnet, all three of those things happen in the same place. I could now today, and very soon with the impending launch, Celestia will be able to do this much more easily, completely separate. I could have my execution happening, say, on my local rollup. I could write my data availability to Celestia, and then I could have ultimately settlement somewhere else. And that's really what this concept means. So now, without going too deep into it, where does something like Hyperlane and its notion of modular security come in? Well, we now have all of these really, really bright and capable teams working to advance the modular blockchain future. Some people want to call it the roll-up centric future. Some people want to call it the modular future. I think these really are, or even in Cosmos, we talked about the app chain thesis for a really long time. I think all of these really are saying the same thing with slightly different names. And that goes back to Sunny's point about like different, geopolitical areas, right? We might all be talking about the same thing, but we all have our different languages because we come from different places. And so in that world, everyone, right now, we're all working towards bringing that world about, and we're making it easier and easier and easier, whether it's with new frameworks for rollups, whether it's with new businesses and tools to make launching your own rollup easier, whether it's, like providing new data availability layers, like what Celestia is doing. All of these things mean that the task of running a modular chain is becoming easier. And so what's the logical next step to that? Well, there are going to become more of them if there is some actual, like, real motivator to do this. If there's a real technological reason where this solution is beneficial, then there are going to be more of these chains. But what the modular thesis kind of, as it currently stands, does not address is, okay, so you have all of these chains. By definition, they'll have an easy way to connect to their settlement layer, but how do they connect to anything else? Are we just going to have a world of just completely disparate chains everywhere? And then you say, okay, well, we have these interoperability solutions, but the permissioned interoperability solutions, which I would say is the vast majority of them today, and I think there's really good reasons for why you would build a system in this like non-modular, much more permissioned way, because you basically say, hey, here is the security setting. It's a singular one-size-fits-all kind of security setting. And we, as the purveyors of that system, we are the gatekeepers of which chains can come in and be a part of this set. Of course, that's quite limiting, because now if you are one of these modular chain builders and you want to get added to that set, you need to go through this form of gatekeeping. So the gatekeeping has a benefit. It keeps some people out, but it has a negative consequence. It keeps some people out, right? The thing that is useful about it is this thing that is negative about it. And so with Hyperlane's modular design, we allow anyone to create different security settings, different security modules. And now you can kind of be the master of your own set. And so with this, there are some great benefits, right? No gatekeeping, anyone can come in. But this can also be used for some negatives, for sure, right? Some people might try and lure you into their chain, thinking like, oh, well, it's secured by Hyperlane, so it must be okay. But actually, like, there is no default security setting for Hyperlane. So someone might pretend like this is a very nice, non-malicious security setup, but in reality, it might be quite a malicious one. And that's kind of the other side of permissionlessness, right? Like, if anyone can do what they want, there's good things that are going to come out of it. Bad things could come out of that too.
So you're talking when you're talking about this this particular, say, like attack vector, are you describing a situation where the destination chain is malicious, or where the construction, the modular construction of the hyperlane interoperability bridge, if you will, between these two chains is malicious? In the same way that you can trust IBC, but you also need to trust the destination chain.
Yes. Sorry. So yes. So that is really what I'm talking. Where like, um, especially in the modular world, a lot of times we're going to be the and I guess the point of Hyperlane is to make it very accessible to the people who are creating their own modular chains. And so in that realm, we expect that certainly the first purveyor of of security, of going into like, if you're going to say be bridging into a new destination chain using something like Hyperlane, chances are that it's that chain that is operating the security. And one thing you can do with Hyperlane is use that chain's validator set if it's a Tendermint chain, or maybe even use that chain's sequencer if it's a rollup as the thing that secures the communication going out of that chain. Now, and what are you doing in that case? You're basically trusting that chain, and so the same the same thing that ends up happening, where like ultimately you have to trust that chain, is going to be happening here. And so if that is done maliciously, people could get hurt. Now, there's another vector with Hyperlane that does not exist in IBC, because anyone can put Hyperlane anywhere. Someone could even do it not on their own chain. They could say create a bridge into someone else's chain. That chain itself might not be malicious, but they create a Hyperlane connection, say between um, maybe Osmosis and this new like EVM chain they create, or could be like a C-level Hyperlane is VM agnostic, so it works in many networks. Uh, and it's not their chain. So it's not that the other chain was malicious, but they're like, hey, no, we made this new bridge. It's awesome. Like, come use it. And they tell you like all the reasons why you should believe it's secure. But unless you look underneath the hood, you might not see that they're doing something that's not so kosher, right? That maybe they're only running it where like the communication is secured by one key. Because again, Hyperlane offers you a lot of flexibility and expressibility in how you secure that communication. And so maybe it's a good time to get into a little bit about like the architecture, and some of this will make a little bit more sense, and why it could be both a very, very good thing, but also opens the door for certain malicious things to happen.
Yeah, I'd like to talk about the architecture before, though. I want to address your hot take, which was that
Oh yeah,
you think decentralized shared sequences are not real. So while we're still on the topic of modularity, can you dissect this statement?
would love to. I'd love to. I love that. First, I have great appreciation for anyone who's working on this problem. It's a very, very difficult problem. Um, but my contention, and is that if you think about what are the actions that are described by what would ultimately be a shared sequencer network, you're now talking about accepting transactions from multiple sources, collating them into a single place, and somehow doing it in such a way where all of those transactions are synchronized, can become atomic, and that at the same time, this is somehow going to afford you scalability that is not found in any of those places individually. And that, I would argue, that is not real. What that is describing is a blockchain that accepts transactions from other blockchains. And I think, for us in the realm of interoperability, we are, we're in a similar neighborhood to to this problem. Because if you think about what Hyperlane does, what any bona fide interoperability protocol does, we accept transactions from lots of chains, and the one thing we're not trying to do is to sync, or I guess some might be, right? But certainly in the case of Hyperlane, because there is no singular Hyperlane chain, we don't try and synchronize these transactions at the same time. We're not sending them to a singular place and collating them in such a way where they later on need to be processed atomically into some place. And so I think that that gives us a view into how difficult this problem is, and that ultimately, if you try to say, okay, hey, I'm going to have 10 different chains, or I'm going to have 10 different rollups, and all of them are going to be sending their transactions to me, and I'm going to allow them to have atomic interoperability, right? So like I'll be able to process their transactions in such a way that they could have atomic composability between them, and I'm going to give them, massive scalability. Those things don't add up to me, because the first thing you need to do, blockchains really are ultimately, a lot of them with their operations are about time. Like, how long does it take to process a block, and like, how does this time sync with other times? And so, first thing you need to do is you need to sync up how often things get processed. Because if my roll up and your roll up are expecting things to happen at a different time, well, that's not going to work in this case. All of us now need to live on like a much more unified block time. And ultimately, that unified block time is decided by that shared sequencer. So I could see how a shared sequencer that is completely centralized could work much better. But now, if you're talking about synchronizing all these different chains and doing it in a decentralized fashion, I don't see how you don't run into the same problems that a network like Ethereum runs into when it tries to ensure that it takes, many transactions, millions of transactions from a maximally decentralized network of nodes. It's this. I view it as very much as the same issue, and that's why I like to, I don't think that this notion of decentralized shared sequencers is truly real. I think it's a blockchain that would take transactions from other blockchains, which is a totally fine endeavor to pursue. But
But then you just run into the same problems again. Like that blockchain will run into the same problems of
yep,
sequencing the transactions of the shared sequencer. I mean, like you just,
totally,
it's
yeah,
like a
yeah. And so,
recursive nightmare. Which, yeah, I mean, yeah, I tend to agree with this idea. I think that as we decouple and modularize different parts of the stack, there are ultimately going to be some parts of the stack that will rely on. We won't be able to decentralize fully in the
yep,
way that like trust minimized systems should be, and it's all about like making the trade-offs for the system that you're building. Like where can you accept a higher degree of centralization, or in this case, like where could you accept less trust minimization at what layers of the stack and what specific areas. But yeah, ultimately, like I don't think you can fully decentralize everything. Yeah.
yeah, that's what it is. I think you could have a shared sequencer that works as advertised. I think you can have a decentralized but singular sequencer that works as advertised. I think having a decentralized share sequencer that works as currently advertised will be incredibly difficult, and ultimately, I think is uh, you know trying to solve the problems of blockchains using a blockchain, which maybe works. I don't know. I've been in the industry for about 6 years now, and I just don't think that is
Slapping
going
on a
to
new
work quite
blockchain
well.
is never really the solution.
Yeah, it might not. I hope I'm wrong, because if I'm wrong, right, like it does mean that this idyllic state can exist, and like
Yeah.
we were talking a little bit before we started recording. I got into this like a long time ago. I just want to see like crypto prosper. Like I've been doing this for a while, and you know, I think that my best way to improve the odds of crypto prospering, of expanding the crypto economy and even accelerating its growth, is through something like working on an interoperability protocol. Could be totally wrong, and maybe uh, a decentralized shares truly can exist. Maybe there are some breakthroughs that we just haven't seen yet that will happen, and yeah, maybe like if it works, that's better for everyone.
So while we're on the trade-off, while we're talking about trade-offs, does Hyperlane optimize for liveness or for safety, or is that a function of the configuration of each sort of bridge?
Okay, you got it. You got it. There you go. This is how I know that it sank in. It You would have like different configurations can land in different parts of that trade-off. And so two simple examples, right? Like we'll keep it maximally simple. You could have a configuration with Hyperlane, and certainly we've also helped people do this in testnet, where transactions are basically validated after a single block on the sending chain. So immediately just showed up in a block. We're not waiting for finality, nothing. Showed up in a block, sign off on them, and then they can be processed as early as the next block on the destination chain. And for those transactions, like, when you're dealing with, faster moving block times, you're talking about like a 5-6 second turnaround time end to end. But what about, what about just like, I could get reorged out of my, especially if we're dealing with Ethereum, we could easily get reorged. If we're talking about dealing something like, I don't know, plenty of chains have like more than one block reorg, right? That's not, no one would get upset or like ruffle their feathers by this. This is just a fact. But you can do that. And so that is something that would be on one end of that spectrum. The other is you could actually say, like, no, we don't process transactions for a really long time. In fact, we would wait a time designated in maybe several hours or days. And a construction that we would tend to refer to as more of an optimistic construction, borrowing from the notion of optimistic rollup. It's not a one-to-one, but it's a cousin, where that you functionally don't let the transaction be processed for a wide array of blocks. And during that time, you allow anyone the capability to observe that transaction. If a fraud proof can be constructed to demonstrate it, right? Because ultimately, like, the action that is being committed on the origin chain, it was included in a block, like we see it, it's there. We can write a proof against that. If that proof can be executed, then now we can veto your transaction. We can block it from ever happening. This, I would say, errs way more in the side of safety. But what does it actually mean to veto that transaction? You actually have to kill the channel. And so you're killing the liveness for that channel. And so those are, I'd say, like the two extremes of, hey, we're going 1-1, where, one block, not so high on the safety axis, or we're going, n many blocks, but we're also giving you the option to basically like eliminate liveness in this situation. Because once a channel is compromised, like, do you even want it open? Like, forget just one transaction going through that looks bad. Like, how do you know that there's not going to be another 10 after it? So at some point, you got to kill the channel. Maybe you don't kill it but you got to kill it. And then you might lose liveness. You will lose liveness for this period until like the new channel is up.
So I guess, but yeah, one last thing I want to point here before we get into the architecture. It sounds like Hyperlane is more of an interoperability framework than a solution. It's more of a framework for building interoperability solutions that cater to the needs of like different sort of trade-offs, like in this case, liveness or safety. Those considerations need to be made on a per app basis, and it allows you to sort of like construct your own interoperability solution, and sort of find the right place between these two trade-offs. Okay, cool.
Exactly right. Now, it does have like some pre-made options, so I like to think of it as, a box of Legos, but there are some diagrams that they're like, well, here's how you build an X-Wing, and here's how you build like a pirate ship. But ultimately, yeah, there's a box of Legos there, and if you want to do some wild stuff with it, you certainly can.
Cool. So let's talk about the architecture. What are the different pieces of this modular interoperability stack, and maybe getting into the modules and the function of the interchain security modules.
Of course. So you'll need three things to basically bring Hyperlane to your chain. And the first one of those we talked about it briefly earlier. It's the mailbox. The mailbox does exactly what it sounds like, as it's the place where mail is sent and received. And think of this as the contract where the interface exists for sending stuff and receiving stuff. So you'd need one of those on every chain. Has a function for sending things, function for receiving things, and it's like your first touch point. Mailbox, of course, is open source. The contracts are verified on the chains that they're on, and anyone can go ahead and put it on a chain that they'd like. So now there are two more things you need. You now need at least one security module. And you could even have a security module where its entire premise is just letting anyone through the door. We like calling this like a no-op security module. But like you're gonna need at least one of those. And it can take many forms. Let's talk about a common one where it's like a validator-based situation, where you would have validators observing the mailbox on the sending chain. And once they see your transaction, they see, okay, Seb is sending a transaction. They might wait for, depending on the configuration, they might wait for finality. We certainly recommend that they do in many cases. And once finalized, they sign off on that transaction. There's both a way to do it where like they're signing, and where the transaction gets added to an incremental called Merkle tree, and they're signing the root of that tree. There's also a like per message signing mode. There's benefits to either, and they concern like different gas costs and different like censorship resistance guarantees. And then the third piece in that validator one, yes, they're observing the sending chain, and then there is a contract on the destination chain that basically says like here are the keys of my validator. So know when those are coming in, these are the enrolled validators in this security module. Now, as an application that is on the receiving end, you tell the mailbox, when I expect messages, route them through this security module. And so now you could choose a single module, or you could do something slightly more sophisticated where you could say, wait a second, what is my user doing? Oh, is my user transferring, say, doing something that is very innocuous, like they're transferring, say, $5? It's their first transfer, it's just $5. Then maybe I'll go for that, something that prioritizes liveness over safety and maybe prioritizes speed, right? Like lower latency. But for other transactions, maybe their transaction is actually trying to drain a liquidity pool. Maybe their transaction is trying to make a very large asset transfer or something, or maybe it's a command to actually upgrade this contract. And so now, given the nature of this transaction, I might say actually route that one through a different security module. So as a transaction goes from the origin chain to the destination, it is not immediately processed. It first needs to go through the security module, and you as the receiving application have some routing ability. You could say, hey, this is what they're doing here. Please send them to this module or this combination of modules. Or, okay, they're just doing this very innocuous thing. Fine, send them to the fast module.
So you can essentially route transactions based on the nature of the transaction. So,
yes.
Or in this case, like if you were trying to upgrade a contract, that transaction might be sent to like a governance contract or something like that.
Exactly right.
And that governance contract would then, unlock that transaction pending a governance vote, etc. That's really cool.
Yeah.
Okay.
Maybe like
so these security modules.
Sorry.
These security modules are modules that are like provided by Hyperlane, or anybody can write their own security modules?
Anyone can write their own, certainly, but we don't see that happening too often right now, right? Hyperlane is still a young protocol. Like we have seen a few being written by outside, like the ZKISM one, which we're super excited about, and there's a few more like those coming. But admittedly, right now, that's a slightly bigger lift, right? We don't expect you to, writing your own module is kind of like going to the restaurant and they let you go into the kitchen. It's like, hey, use the ingredients. We got like the best steak in town. Go ahead and make it yourself. So that can happen. I would not tell you that it's like the most common approach. The more common one is we have these pre-made ones, and then you decide how to use them. And so you don't need to do kind of completely writing it from scratch. It's you have a module where you designate a certain amount of, you say, hey, I want these keys to sign off, and those keys might be your validator set. They might be your, whatever is like the key for your DAO, as you mentioned in that governance case. Keys might be a subset of your validators that you think are, more relevant for specific transactions. And that those are much easier to use, right? Like in that case, you're not rewriting much. You're just taking something off the shelf and you're inputting certain parameters into it and working that way. And so that's the security part. And the third thing that you need to have a Hyperlane integration is basically in between those chains, you need to have what in Hyperlane terms we call a relayer. It's pretty similar to IBC relayers in the sense that you're not really trusting this relayer with the contents of your message. The relayer can't meddle with the contents. They are purely like a messenger. And right now, senders, when they pay for their transaction, they specify the relayer they're paying for. What we're moving towards, and this will happen sometime in the next, say, 6 to 8 months, is more of a relayer like marketplace, where instead of paying to a relayer that you pick in advance, you are putting the payment out there kind of like a bounty, and then these relayers start looking a little bit more like interchain solvers, because there's a payment put up by me, the sender, and my transaction tells the relayer like what I want done, and then they just need to go and get that done on my behalf by processing that message on the other side.
That starts to resemble more of like an intent-based system.
That's right. Yeah.
At that point, okay.
I don't know that all interoperability protocols have picked up on this, but I view very thin. I see a very, very thin distinction between an interchain intent system and an interoperability protocol. Interoperability protocols right now might be more narrowly, much more narrowly defined intent systems, because we're limiting it to like, hey, I want to swap this, or that language just hasn't penetrated yet. But like you can, when people talk about like, oh, intent-based architectures are like far away, you could actually realize one today using something like Hyperlane. If you build you could build an application that allows users to much more easily express an intent beyond just say something like limit orders, and then have Hyperlane relayers basically fill those orders, and they it's just different language, but they would actually ultimately just look like solvers.
So I guess like does this, I mean, because so there's no coordinating chain. So this is very different to something like Axelar, where Axelar, the protocol, sort of sits at the middle and is coordinating this message passing and the sending of assets. Mm-hmm. So there's no central coordinator that's doing any of that. It is purely like a chain to chain messaging protocol, where like messages are received on chain A, a relayer sends messages to another chain, and then a security module or a configuration of security modules there will relay those messages based on the types of transactions they are, and then they may have to go through additional steps in order for the transaction to actually hit the chain and be executed. I mean, that kind of sounds a little bit like IBC to me. I don't know.
It's very similar. I would like to say that Hyperlane doesn't exist if not for IBC.
So what is the key difference? I mean, because IBC sort of exists as a spec, right? Like, does the IBC spec, is it lacking in its functionality where Hyperlane couldn't have just implemented the IBC spec and maybe like add some security add some sort of features like the security module that I think really augments the security of interoperability between chains. So what's the difference, I guess,
as
between
it stands is very complex and was kind of built, I don't want to put words in people's mouths, but I think if you look at it, it was built with a certain chain construction in mind. And really was designed at a time where if someone said my blockchain design is going to be the most dominant one, you would believe them. Like that was a reasonable statement to make 4, 5, 6+ years ago. Today, where we see a number of designs, certainly the EVM might be the most dominant, whether it's good or bad, right? But there are good reasons why we still haven't seen, um, you know, that there are not many reliable IBC implementations for EVM chains is not coincidence. It's not for lack of trying. It's not that there's not enough smart people trying to. There's many smart people working on this. Uh, it is that, in my view, that the IBC spec is quite complex and was designed with Tendermint chains, or something that looks like a Tendermint chain in mind, right? A chain that has like client verification, a chain that does have fast finality. But for us, we wanted to focus on extensibility. I wanted to see something that ultimately could let anyone connect any chain. Now, IBC lets anyone easily connect a Tendermint chain. But I'll give you one example, right? Like the callbacks that are necessitated in IBC are very useful in the context of two Tendermint chains talking to each other. But you have to, so basically, like, you have to send, like a callback is being sent from the destination back to the origin to kind of let them know, like, hey, we're all good, the thing happened. If you're dealing with like slower finality and more expensive chains like Ethereum, now you made that interaction much more onerous. And so implementing the IBC spec as it is something where it would have limited, or at least in our view, would have very much limited the extensibility of.
So then, how are callbacks treated in Hyperlane? I also wanted to ask you about that. Yeah,
they're not required.
they're
The
not
gist of it.
required.
Yeah.
Okay.
So you
So you
could
could send
design.
assets to another chain and not know whether the assets were minted
Yeah.
on
So
the
the
other
way that
end.
is handled through a much more like call it like less rigid process where you could just check like the Hyperlane Explorer, let's say, and see, oh, well, my thing arrived. Uh, but
Okay.
observing what happened on the destination, we think achieves that same benefit in majority of cases. Um, and
So you're sort
so,
of relying on the application to check
correct,
rather
and giving them the
than
tools to make that much easier.
right. Okay, rather than the chain actually getting a confirmation that
Exactly, yeah.
yeah.
Because
So I
once
think
you're
this is really
outside of the
interesting.
yeah. Oh, sorry, go ahead.
I think this is really interesting because I was thinking about the web, right, and how like interoperability happened in the web, and you were talking earlier about how like your email communications were hindered back in the 90s, and then it all kind of like fixed itself. But I think interoperability in the web really happened if you take a step back and look at computers, right? So you have like Unix computers, you have Windows computers. There might be like other types of OSs out there, and interoperability between these systems happened at the application layer. So like we're talking right now through HTTP, and you could be on a Mac, I could be on a Linux computer, any other computer, as long as like we're in HTTP and we're in a browser, we can interoperate because that application layer interoperability works. We're not like talking at the kernel layer. We're talking at the application layer through a protocol which is called TCP/IP, right? And it seems like what you're describing here is you're relying on the application layer to ensure that finality happens rather than like the protocol actually enabling the interoperability.
That's I think that's an apt description. We do leave more to the application layer because I think the if you want to be more extensible, what's at the other end of that is being more rigid. And if we want it to be more rigid, like IBC is already there, right? Uh, but with the expressed goal of kind of maximizing the extensibility. And I think this has been proven out as now we've seen. And the coolest thing is that these are completely separate teams. This is not our team. Hyperlane has been built for Cosmos SDK, for Move, the Move VM, and for even it's even being built for Cardano's environment. And then as well as a number of smaller, more bespoke VMs by teams like Cadena and teams like Masa that have, again, more unique constructions. And they're implementing Hyperlane for their own environment. And if we opted for something, again, that's much more, that does all of that within the protocol, very unlikely for that could have happened.
Interesting. So I want to take a step back and just go
Of
back
course.
to what we were talking about earlier, and the role. Like, who are the? We talked about validators. We talked about relayers. Can we just expand on the role of those two, like parts of the transaction? Those two participants in the transaction, and are there other participants that are facilitating the transaction, and what are their roles?
Of course. So we'll start with the relayer because that's the easier one. The relayer needs to be involved in every Hyperlane action between one or more chains. And it is, it's the Hermes of the system. It's the messenger. It uh, a relay anyone can run a relayer. It's open sourced it. It's a fairly simple operation to run. And what a relayer does is it observes the mailboxes of the chains you want to connect. You can have a single relayer that's observing, say, even like 15 different chains. And as it observes these different mailboxes, it sees, hey, Seb is sending something. It looks like he's got a little treat for me in the form of a fee. I like those fees. It help me run my business. And then I check, wait a minute. Okay, so in their message, Seb says that it's going like to this place, this application, and that these are the security modules being used. Are there valid signatures tied to this? They're supposed to be at this location. Maybe they're on IPFS, maybe they're on like some publicly available like cloud destination. I find them. Everything looks good. I initiate the processing. So that's really all the relayer does. It is involved, again, as I said, in every Hyperlane transaction. Um, because anyone can run one, you could even envision a situation where users are doing it, right? Like I remember seeing sometime in the last 2 years, like a really cool script that allowed users to like inject their transaction, or sorry, to relay their own like IBC transactions. That is ultimately possible with Hyperlane as well. Full disclosure, not not happening right now. No one's. I guess someone tried to do that in the hackathon once, but it wasn't what we call production grade, even though they put a valiant effort. Now onwards to something like the validator. Uh, Something like
So
a
so
valid, or
just
sorry,
just one second, like on the
oh yeah,
relayer,
of course.
the relayer is so the relayer is remunerated for this work, obviously,
It
but just
doesn't
to come
have to be,
back,
but you hope that it is.
sure.
If it's not, why would they do it?
So just to make this comparison to IBC once again, that the difference with IBC, because IBC does have relayers, is that there is no like client verification. So like chain B is not checking chain A, and chain A is not checking chain B. Right.
Yep, that is
Okay. Okay.
that is
Interesting.
correct.
And then so when the relayer sends that
Because the relayer is
transaction,
not tied to the security mechanism in any form or fashion. The relayer is purely a messenger, whereas in the IBC case, right, like the relayer, again, I think I wouldn't say that it's tied to the security function in a way that it performs it, but it relays something about it.
back to the chain.
Whereas,
Yeah.
yeah, in Hyperlane, the security module, which can be expressed through the validator agent, is where that happens. So there's a world where the relayer relays something to the destination, and and then it gets blocked by the security module, where basically like getting relayed is not a guarantee of anything other than getting relayed. So a transaction can still not arrive at its ultimate destination based on the logic uh, where it gets ran through the security module. That
Okay.
can happen and is expected behavior.
Got it. Okay. And so we understand the relayers now. So the validators play a role in specific security configurations, so specific security modules. They don't always play a role, but they can play a role.
Yes. I think that's a good way to put. But like they don't, yeah. So they no decided role in security. They're purely a messenger, and then all of the security handling is related to like what they're transferring something from uh, like from one chain to another that is completely secured by the chosen security modules. And if it were to be, altered in any way, the signature that they would be passing along would not match the signature from the security module. And so something would be amiss, and that message would just kind of fail by default. Because what happens on the destination chain is that relayer, it initiates a function in the mailbox called process. And what process does is it looks to the contents of the message and it says, oh, okay, well, I'm supposed to go to, here's what I'm supposed to do. I'm supposed to go through these security modules. Okay, cool. Let's run the logic there. And the logic might say, oh, well, is there a signature from this validator? Is there a, or if it's like the optimistic model we talked, has it been enough time? Like, okay, yes. Has it been enough time? Check. Has there been a fraud proof submitted? No. Check. Okay, move on to your destination. If you fail any of these, like that's it. You never get past the mailbox. And it is totally intended or expected behavior for lots of transactions to never make it past the mailbox.
Got it. Okay, very cool.
And so there comes in like the role of the security modules, and like they can take many forms. We have some presets like one that's more of a proof of authority one where you designate which signers. We're about to finalize an economic security one where it's that same concept of the proof of authority, except now those signers also have value at stake. This enables a really cool form of restaking as well because it can accept any asset as given. And then, yeah, like I said, people can kind of bring their own, they can bring their own home cook in there. And so it opened the door for a really cool team in Electron bringing their ZK Lite client as a security module.
So in the case of roll-ups, so if you take a roll app or a roll up where the roll up doesn't have validators itself, it is relying on other layers of security, and the validators sort of sit at the bottom layer. How would that particular security module work there? Who would be signing or like doing
Great
that
question.
verification?
So let's say if you went with like the easiest setting, the authority-based one, you're now as the initiator of this, you have to designate like who is going to be signing the messages that go out of my role. And so you could lump it in with your sequencer. That is one setting. Uh, at that point, I think that is the preferred setting because as a roll-up user, to me, that just says I'm receiving the same trust model as using this roll-up just any other setting. Um, so that's one possibility. The other is validators that are either related or unrelated. So you can like kind of bootstrap a consortium small as you may want validators. They might even be putting value at risk, like they might be staking, Atom. They might be staking your whatever is your native currency on that rollup, because obviously not all rollups choose to use the same gas currency.
Okay. And so, yeah, which brings me to my next point, which is gas. I know you guys have some, like a gas module. How does that work?
Yeah. So one thing that would be really unpleasant is if gas wasn't handled by the protocol. If gas was left on to the user and you do everything we talked about, but you would also need to specify where you own the gas tokens on that destination chain. That's kind of shitty. That doesn't accomplish almost anything of what we wanted to talk about. And so we have to have a way for Hyperlane to deal with destination gas for you as the user. Because again, right, like if you were initiating a transaction from Osmosis and you're ultimately executing it on Arbitrum, like if you needed to hold ETH on Arbitrum to do that, that's really unpleasant. That's really not great. So the way that Hyperlane handles it is through the relayer primarily, and that's really the reason why they're collecting a fee in most cases. So this is not a committal role, but almost everyone that runs a relayer does this, again, because otherwise the service they're providing is very, very thin. And so the relayer will hold the balance of the gas tokens of the chains that it's connecting. And think of them kind of like an inventory manager. So it charges you on the destination chain in the local currency, but it charges you an amount that basically covers its expenses for processing your transaction on that destination. So going back to that osmosis to Arbitrum example, you're paying an Osmo on osmosis, but you're paying the full amount that includes the tally for what the relayer is going to have to pay on your behalf once you get to Arbitrum.
Okay, that makes sense. So you guys just recently released Hyperlane V3 with some notable improvements and for developers. Can you talk a little bit about what's new in Hyperlane V3 and
Yeah, so with Hyperlane V3, there's a couple new things, but the most important one, and it might not be most important for everyone on the core team here, but it's the most important to me certainly, because this has been like a thing that's been bothering me since day one, is that now there are two functions that you needed to hit to send a message with Hyperlane. You needed to initiate a function called dispatch, and you also needed to initiate a separate function, which is like the interchain gas function. So you said, "Hey, I'm sending this thing," and in that same transaction, you said, "By the way, I'm paying for that thing over there." And there was a good like technical reason for why to do that. Well, the protocol was early; it prevented like too early of ossification, etc. That didn't mean we liked it. I certainly did not like it. It felt kind of janky. And so that is now lumped in. There is a dispatch that basically allows you to pay at the moment of dispatching without the need for a second call. Again, this might seem small, but when you are like us and we work very closely with the developers that build on Hyperlane, we feel their pain. And, doing this so many times and seeing so many people like, dang, I forgot to do that, which is like, I understand, because it's kind of like you go to the store and you go through one counter and they say, hey, I'm buying this thing. And they're like, cool, you're good. And then oh, no, you pay over there. And so that is something that always bothered me. But that is not, the most exciting to me, but certainly not the most exciting. The bigger innovation is the addition of what we call hooks. And so hooks are an easier way for people to bring into their transactions security mechanisms that are not, like Hyperlane native, let's call it. So imagine you are transacting with Optimism. Maybe going into Optimism, you would just rather use the native bridge. So hooks let you do that much more easily. They let you kind of route the transaction through mechanisms that have nothing at all to do with Hyperlane. And that kind of extends on this point that I made earlier on of for us, it's about being that interface. And so now with hooks, it's even more likely and more easy to use Hyperlane as a singular interface and route your transactions through whatever mode you find ideal for the task at hand.
So who's building on Hyperlane, and are you able to sort of track the volume of transactions happening in the, say, Hyperlane ecosystem, if you want to say call it that, right? The ecosystem of
Yes and
applications
no.
that are using.
Yes and no. This is something I am very unhappy about. So, um, yes, on chains that we know about and track, no, where we don't. And so, right now, like if you go to the Hyperlane Explorer, it tracks chains where there are deployments that the us in the core team have played a role in. And these are and what's being tracked is the movement between those mailboxes. Those are again mailboxes that we know of and are aware of. If you put Hyperlane on your own chain tomorrow and you use it to communicate with it, uh, we're probably not going to know about it unless you tell us. And so that we don't. There's some like telemetry stuff that we can do, but isn't done yet, kind of in the in the freewheeling spirit of crypto, and it is unfortunate, I would say. But yeah, we don't get a full picture. So um,
I mean, it's kind of a feature and a bug, right? I mean, it's
yeah, exactly. Now, it's something that we're working to make easier for people who are like growing the hyperlink. So we are creating a registry where people can more easily add like, hey, I just forked Hyperlane and I put it on Aptos, or hey, I'm just, I'm putting it here, putting it there. Um, because certainly by now, there is many deployments of Hyperlane that have nothing to do with the core team as there are of the ones that we've played a role with. And that's certainly the goal, right? Like I want to, a year from now that the vast, vast majority of them have nothing to do with the core team. I think that is ultimately like what it means to have a decentralized protocol. But certainly from a day-to-day perspective, it's like, oh, we can't see this as easily. So to your other question of like, who's building with it? It's primarily, I like to talk about, kind of we have a lot of themes that we draw from Star Wars. Our name actually is Hyperlane in the Star Wars universe. I actually didn't know this until one of our colleagues proposed it. Hyperlane is like the easiest path, the safest and fastest path between like star systems. It's what they use to travel between star systems. And I was like, oh, this is a
it's the
great name.
warp of Star Wars Star Wars
Yeah,
jumpers.
exactly. It's like the warp drive path. And so, he's more of a Star Wars guy. I'm more of a Trekkie. My dad, rest in peace, he was a massive
Same,
Star Trek
same.
fan. And so we have like a little bit of both where we've created like
Someone's gonna
one of
build
our
a competing solution, and they're gonna call it warp drive.
well, we beat him to it. We beat him to it. So we have warp
Oh right, I
routes
know.
where like the
Yeah.
easiest way to bridge assets with Hyperlink to bring them to any new chain is through what we call a warp route. So that was like sticking some Star Trek in there. Stuck it. Uh, but so there's with our expansion into Cosmos through the Cosmos and ultimately the Cosmos SDK module. We'll likely be live on chains like Osmosis, and now we're working very closely with Neutron, which we're super excited about. And all of these can be used now as a hub to reach other rollups. We've been working very closely with the Celestia team on a number of initiatives. We want to play a big role in how rollups that use Celestia for DA are able to continuously do that, easily do that, and securely do that. Uh, Beyond that, we are pretty much solely focused on the rollup or modular ecosystem, or as you want to call it, the app chain ecosystem. I think all those words kind of combine into the singular thing. And that has been most of our activity. But that said, we still have a number and a growing number of just what we call interchain applications, or just think of it as like just straight up apps, not just app chains that are incorporating Hyperlane. Most recently, um, Aave for its new governance initiative, where they are transferring governance between chains, elected to use Hyperlane alongside Chainlink and Layer Zero, which we think is really cool. And then there's a number of smaller apps like Damn Finance and Yama and Superform that do different like DeFi things. Some of them are like interchain stablecoins. Some of them are like an interchain lending protocol that are using Hyperlane between a more, let's call it established set of chains. But through Hyperlane, they have the ability to expand to any chain they want and no reliance on us. So one of those teams, Damn Finance, they wanted to have their application be available, specifically have their stablecoin be available on a chain that none of the interoperability protocols were covering in A-Star, a chain that is quite big in Japan. And they brought Hyperlane there by themselves, right? And that is something that we think is like really cool, really powerful, and it's kind of it's the thesis at work.
Very cool. So how can developers start using Hyperlane on their chain? And yeah, what would you like to call upon our audience to do?
Great question. So what I'll say is, if you are an app developer building, you know, you're not interested in creating your own chain, still reach out, either join our Discord or follow us on Twitter. If you want to have some interchain capabilities, come to us. We can show you how to get started. The docs are obviously a great place, but don't be shy. Again, as I mentioned before, uh, there's a whole community of kind of Hyperlane builders that is very happy to help new people coming along, and you could find us all in the Discord. And so certainly do that. If you are building your own chain, if you wanted to start testing around with Hyperlane, you can follow the deploy guide. If you know that's something that you want to do, but that's not something you actually want to deal with, we are now offering access to Hyperlane where our company here will basically run Hyperlane for you as a service. So even if you're like, hey, I want this, but I don't know if I can run it myself, don't be shy. Just come, we'll do it for you. That's becoming an increasingly more popular option as we help people get off the ground. And the cool thing about it, there's no lock-in. So because of Hyperlane's architecture, the ultimate ownership and responsibility can be transferred over. And so you could get started with someone else doing it for you, and then quickly, as you get your sea legs from under you, you can just say, hey, you know what? We're good. We learned how to do this. Let us take over now.
Yeah, which was one other question I wanted to ask. What's the business model? How does Hyperlane make money?
So there's two. There's the business model that Hyperlane and the protocol might adopt, and that I think looks like a quite simple one where you give chains a chance to opt in to a specified set of security modules where they'll also be sharing some of the fees with some like Hyperlane DAO. That's one option. Or sorry, that's for the protocol itself. Beyond that, there's like, well, we formed a company, we employ people, and for us, we'll be looking to continue to provide services on the relayers and services on setup, um, which just look very much like a kind of boring software business, but boring software businesses are acceptable.
Sometimes boring software businesses make the most money. So
sometimes they do,
yeah. Great. Jon, thanks so much for coming on. I have like so many more questions here, but we're running pretty long. It's been really fascinating, and yeah, I really look forward to seeing more come out of Hyperlane. And I mean, I think just generally, like, interoperability protocols are great for the ecosystem as a whole, and we want to see more easier liquidity flows between different domains of state, different ecosystems. And really glad to see Hyperlane performing that function with a really interesting and novel design. So thank you.
Well, thank you so much. It was great to be here.